Yo guys, in this video we will be doing the derivatives of log base of something of x maybe. So the simple rule is that if you are looking for the derivative of in log of a certain function, what you will do is you'll say the derivative of in log of x, which is the outside function, is 1 over x, but this is v, it's not x. And then you derive or differentiate the inside, which is v, so you find v prime. That means the derivative of this is v prime on v. Now the derivative of log base of some constant of some function f at x is equivalent to, this is a bit different but it's very similar to, you derive the outside, which is log base of that thing of some function, so that outside will be 1 over, you put the function f at x. Now much like the exponential function, here you include in log of the base a in this case, and then you differentiate the inside, which gives us f prime x. Now this simplifies to f prime of x divided by f at x ln a. Right, these are our rules. This is what we are going to be using in this video. Now the first problem we're gonna do is we have to find the derivative of ln x. Simple problem. So for the derivative of ln x, we say it's the derivative of the inside, which is x. The derivative of x is 1 divided by x, because you have to have this on the inside out. Now the second thing we're doing is the derivative of ln 2x squared. What I'm going to do from now on is I'll start by writing the exact function on the denominator, just so we don't forget that. So the exact function is ln 2x squared. It has to be there on the denominator, it's always there. And then on the numerator you have the derivative of this, which will be 4x. That's how that is. And the 2 goes into 4, which means we just have 2, and the x goes into x squared, which means we just have 2 over x. That's what that simplifies to, it's just 2 over x. The third one is find the derivative of ln x squared plus 4x plus 1. This one is still applying the same rules. It's still ln. So we put the same function, this, on the denominator, x squared plus 4x plus 1. And then in the numerator we put the derivative of the function, which means we have 2x plus 4. Right. number 4 is a bit different. We are doing the derivative of log base 2 of x squared. Right, we've been doing the derivatives of ln, which means we just had to put the same function on the denominator, this one, and then on the numerator we square we find the derivative of this. Now, for this one, we are going to be using this rule, which means we want to have the function on the denominator, and then we say ln base, so ln of the base, and then you have the derivative at the top. So the only thing you're adding now is just ln base. It's still the same as before, just adding ln base on the denominator. So we say, let's put that exact function on the denominator, x squared. On the numerator, we want the derivative of this, which is 2x. And then we just need to add ln 2. That's your answer. You can further simplify, say x goes into x squared, and now you have 2 over ln 2. I'm reasonably confident there's another way to simplify this further on, but I don't think it's worth the hassle, since it didn't pop out my head immediately. So now we are going to find the derivative of log base 7 of sine squared x. For this one, we do the same thing we did here. So what we are going to do is we put the exact function as it is on the denominator, sine squared x, that's our function, and then we need to put the derivative of that on the numerator. So this sine squared x is actually two functions, the outer function, which is something squared, and the inner function is sine x. So we'd have to use the chain rule to differentiate this. So to use the chain rule to differentiate this, we differentiate the outside, which will give us 2 sine x, and then the inside, which is sine x, and it gives us cos x. Now we just need one last thing. It's ln 7, which is ln of the base, because if you have log, you have to have ln of the base here. Now this simplifies to be, okay, there's multiple ways you can do this, but you can say this is sine 2x, and then that means you have, let me show both ways. This will be sine 2x times cosec squared x divided by ln 7, I guess. I don't feel like that's simplified enough, so I prefer the way where you just cancel out one of the signs, and then you have cos over sine, which is cot, so you have 2 cot divided by ln 7. Yeah, that looks way simpler. Let's do the last one. The last one is find the derivative with respect to x of log base pi of sec squared x minus tan squared x. Now, this has log, which means that we have to do it with the way that includes ln on the denominator. But I would like us to deal with this first. I would like us to deal with sec and deal with tan, so that we have simpler functions. So we have d on dx of log base pi. This sec is actually 1 over cos squared x minus this is sine squared x over cos squared x. Now d on dx will be d on dx of log base pi. We take the same denominator, cos squared x, and then we have 1 minus sine squared. Wow, I did not expect this. So we have d on dx of log base pi. 1 minus sine squared x is actually just cos squared x. Cos squared x, which just goes away. Now we have d on dx of log base pi of 1. And now this is a constant. Log base pi of 1 is a constant. Because pi is a number, 1 is a number, nothing is changing in this thing, and therefore this is a constant. Derivative of any constant is 0. But if you want to try it, or you don't understand that it's a constant, you can try to use the same rules to get the same answer. So to use the same rules, you say you put f at x on the denominator. F at x would be 1 in this case. And then you'd say ln pi. And then on the numerator, you'd put the derivative of 1, right? d on dx of 1. Now we are sure that the derivative of 1 is in fact 0. 1 times ln pi. Now 0 divided by anything is just 0. So that's your answer. So the derivative of this is actually just 0. The whole function is a constant. Let us try doing that without simplifying this way and see if we get the same answer. Which we should. d on dx of log base pi of sec squared x minus tan squared x. Okay, I don't know the derivative of sec directly, so what I'm gonna do is I'm gonna write sec as 1 over cos log base pi of 1 over cos squared x minus, but I know the derivative of tan squared x, it's sec squared x, so I'm gonna write tan squared x as it is because I can differentiate it. Now what I'm gonna do is I'm gonna write the entire function as it is on the denominator. So now we are finding the derivative. So I'm going to write the entire function, which is 1 over cos squared x minus tan squared x. And then on the top, I have to find the derivative of this function. So for the derivative of 1 over cos squared x, I have the quotient rule. I will link to the quotient rule on the top corner of the video. So for the quotient rule, you have cos squared x all squared on your denominator, and then here you have the denominator cos squared x times the derivative of the top, which is 0, so it goes away. minus 1 times the derivative of the denominator. It's negative. Okay, shoot. So to differentiate cos squared x, we use the this is such a pain in the ass. Sorry. We use the chain rule. Differentiate the outside, which is 2 cos x, which is something squared, so we get 2 cos x, and then differentiate the inside, which is negative sine x. Then we are done with this one. We are going to this guy. We have negative. We differentiate the outside. It'll be 2 tan x, and then differentiate the inside, which will be sec² x. We are trying to get the same answer. We should. Well, you're not forcing it to be, but don't forget to add your ln base. Now, this we have cos to the 4th power on the denominator. Here we have 1 over cos squared. We have 2 and 2, which we can take out as a common factor. I'm trying to see what's the fastest way to do this. This tan is 1 over cos, so we have cos to the 3rd power on the denominator here. We also have cos to the 3rd power on the denominator. Okay, so what I'm going to do is I'm going to take out the 2 as a common factor. We have 2 right there, and the negative sign. And then I'll open up the brackets. Here, this cos will cancel out. These cos will be 4, because the 2 and the 2 multiplying give you 4. And then one of the cos's at the denominator will cancel up with these cos's, and then you have negative sine x divided by cos x times 1 over cos squared x. There's a reason why I'm doing this, you will see in a few seconds. So multiplying this will still give us cos to the 3rd power, because we have cos to the 3rd power now since one of the cos's was cancelled. Now we have a positive there. We have sine x over cos x. Then sec is 1 over cos squared x. Actually, that's very simple. So this is the same as this exactly, which means it's just 0, because this is negative and this is positive, and it gives us 0. So our denominator doesn't matter anymore. You should probably write it on an exam, but the answer is 0, because you see this is sine over cos, 1 over cos squared, 1 over cos squared. This is negative, this is positive, so it's just minus this plus the same thing. It's just 0. And if it's 0 on the numerator, it's just entirely 0. Thank you for watching. We will meet you on the next one.